evening and welcome to this program of the New York University Abu Dhabi Institute. We're delighted you're all here with us. My name is Mariette Westerman. I'm the provost of NYU Abu Dhabi. And tonight is the first in a series of programs, 3 programs through the spring, that goes under the header Abu Dhabi Futures and Urban Planning. And what this series tries to do is identify a number of acute urban opportunities and challenges, you could say. And they are opportunities and challenges for any type of world city, whether in the UAE or Europe or Asia, Latin America or the United States. And we then also, when we look particularly at challenges that in a way unite Abu Dhabi in unusual ways, or Dubai, as is the case tonight, to New York City, the original home of New York University. It's often thought that New York and Abu Dhabi are almost too different from each other to have any connection at all, and that doesn't turn out to be true at all when you analyze these the kinds of cities that the UAE has and New York City for their some essential characteristics. In the case of Abu Dhabi, of course, it's island nature, it's an extremely low level coastal situation, and it's quite in its moments of quite extreme climate, both here and in New York. And those are characteristics that obviously unite these cities. Certainly, Dubai has seen mega growth very recently. New York has gone through that process much longer ago. But again, the problems and opportunities that come with such large urban infrastructures and cosmopolitan communities, of course, unite the cities in many ways. Tonight, we are going to look in particular at strategic issues facing New York and Dubai. And we have here with us tonight to illuminate these questions absolutely the most wonderful expert we could have possibly hoped for. His name is Dr. Asaf Ashar, and he comes with more than 30 years of experience and expertise in matters of shipping, maritime management, and port questions, and multimodal transportation. As I studied his CV a little bit, I realized he was quite a multimodal person himself, having worked in different kinds of institutions and with a very deep background, having obtained various degrees in engineering, industrial engineering, in marine system management, and also in maritime studies and international transport. And he has practiced in industry literally all over the world. So he brings a fantastic comparative perspective to the questions facing Dubai and the port of New York, larger New York. He's worked in Central America, Asia, Europe, the Middle East, North America, you name it. So I really look forward to his illuminating matters for us. He is now, after those many years of practice, he has become a research professor at the National Ports and Waterways Institute, which is an institution, a maritime research institution of the University of New Orleans. He is the head of its operations in Washington, D.C. Before I yield the microphone to Dr. Asaf Ashar, I wanted to say something about these programs to follow. In April, in the same series, we have 2 programs that you'll see announced very soon. One, of course, very germane to the low sea level. I already mentioned the low level of the cities that unite our university campuses. One of these programs will be dedicated to the rise of sea level, and that talk will be given by a professor who is very adept and really researches with very complex statistical and atmospheric models the likelihood of the sea level rising and how fast that might happen. He is coming to certain predictive models on this. That's April 11th. And on April 20th, we will have another professor from University College London speak about mega projects, the mega projects beloved of New York, Dubai, and Abu Dhabi. So we hope to see you there. these very same speakers, or rather topics, are being addressed on a regular basis also at our counterpart institute in New York City, in New York. We have opened at New York University a wonderful house smack in the middle of our historic campus at 19 Washington Square North. If you find yourself in New York City ever during the academic year, check in with us, check out our website, because we have a very vigorous range of these programs that you've been coming to hear and enjoying here going on there, including this exact counterpart series with different emphasis in New York City. But now, for the speaker we really have come to hear, Dr. Asaf Ashar.
Our program tonight, as you see, okay, is some kind of a comprehensive. Go ahead, take your seats. And as you see, I'll start with a brief history, one slide of the industry, and then I'll go through the components, and I will end up with some kind of a comparison between New York and Abu Dhabi, Dubai, which I see is one complex. And what is my claim? You see, I will talk about threats and opportunities, which means some kind of a strategic analysis. And I will make the claim that there is some similarity between New York and Abu Dhabi, Dubai, when it comes to ports and shipping. So that's what I will try to make the claim. So, history of shipping. This fellow, Malcolm McLean, okay, in '56, he was a trucker. And the guy used to come to the port of New York, by the way. And he had a truck full of merchandise, and he was waiting and waiting and waiting and waiting. So we thought, why don't we, okay, take the entire truck, instead of opening and taking the merchandise, why can't we separate between the box and the wheels and take the entire box and load it on a ship, okay? And there were no container ships. He took a tanker, the Ideal X, that was the name of it, okay? And he strengthened the deck of the tanker. A tanker obviously has all the tanks here. He didn't use them. He bought it because it was very cheap. He strengthened the deck and mounted the containers here, using, for the purpose of it, a construction crane and a device which we still have it now. It's called spreader bar. The container has 4 holes, and you lift the entire container. Now, the first use of container was for coastal shipping in the US, between New York and Houston. And why? Because if we look at the 50s in the US, you know, the US has many states, like here in UAE. And each state used to collect taxes. If you wanted to go from New York to Houston, you had to cross about 10 states. Every time you cross a state, you have to pay taxes. So he was a smart guy. He said, if we go by water, we can save on the taxes, and the vessel is cheaper. So I happened to meet with this guy once upon a time. And he's the father of containers. I expected somebody like Isaac Newton, I don't know, or Albert Einstein. No, the guy was down to earth. Very simple. And I asked him, you know, after a small conference, what was the idea? He said, I did not invent the containers. What do you mean? He said, containers were before me. And this is a true story. The US Army used to have metal boxes. The US railroads used to have boxes. I just used them. And why did you go into all this revolution and say, what revolution? I wanted to save a buck. This is it. So like every revolution in America, like the first one, people wanted to avoid taxes. This is a source of revolution. Okay. Let's go to the element, the container ship. Let's go to the biggest one now on Earth, the Emma Maersk. What you see, first, it's a fully cellular. It's not a deck ship anymore. You use the entire hull. Now, the nominal capacity, as you see here, it's 11,000. Our calculation in the industry is 14,500. The size, in terms of dead weight, is 150,000. It's the largest even now, and the dimensions are huge. 396 by 56, 15.5 meter, which means that when the vessel is fully loaded, and usually Maersk is very conservative companies, they wanted to have 1 meter below the keel, you need at least 16.5, perhaps even 17 meters of channel. Now, the ship itself cost $180 million. The boxes on the ship, another $80 million. The terminal, at least $100 million per berth. Now we are more. So what you see, containerization, just push forward the idea of capital cost. Very, very intensive. You need to have boxes. You need to have ships, which was a big revolution in all this shipping business. Suddenly, instead of taking some ships, taking a couple of bags, or maybe barrels, and go from a port, small port to small port. Here you have a mammoth ship. Supposedly, if you want to go from Asia to Europe, you need at least 8 or 9 of them. So you're looking at more than $1 billion, just the vessel itself, and half of it just in the boxes themselves. So suddenly, multi-billion dollars. The industry is very capital intensive, and when it was invented, some people blame the US that US-based shipping would like to dominate the world by the sheer power of capital. Now, the port itself, also, if you see here, this is a propaganda, by the way. It's one time they wanted to show that it's possible. The vessel is served here by 10 gantry. It's uncommon. Usually the vessel is served by 5 or 6. And the productivity, as you see it, is huge. 543 moves per berth hour. It has never been surpassed since then, but it was only a demonstration. So we started with a small tanker, and this is where we nowadays. Big, huge vessels, 400 meters. Now, it's not the largest vessel that was conceived in the industry. There were even larger. As you see, the Malacca X was a project by my colleague in the Netherlands, by the way, Nick Weinholz. And he decided that the most constricted waterways, the Malacca Straits, let's build the vessel, the largest vessel that can fit into the straits. The depth of the straits is about 22 meters, so he decided to go to a vessel which is 21 meter deep and very, very wide. No port in the world can handle 21 meter, and even the Suez Canal cannot handle 21 meter. Let's look a little bit at the technical feature. The bridge of the vessel was moved to be up front, so there will be no obstruction to the pilot. The hatches are open. There are no hatch covers, okay, to save on time. There is a double screw. All vessels now, all container vessels have only one engine. They couldn't fit one engine to such a big ship, 2 of them. And also another technicalities, if you see here, that's cross section, there is a lot of space on the side. So in order to get stability. Now, the use of the vessel was, as the Dutch people thought, is to do a shuttle between Singapore and Rotterdam. Now, because the Suez Canal is not deep enough, they thought of a deal. They will come to the Egyptian and they will offer them some kind of a loan to deepen the Suez Canal in order to make this one available. The only problem was that when they did their calculation, the saving in operating this type of vessels were only $40 per TEU. I'm sorry. Only $40 per TEU, which is very, very small. Because if you look at the typical freight It's probably in a 1500 now. So saving of 40 cannot make the deal. Let's look at other trends. Speed. As you see here, about 10 years ago, a group in the US came with the idea of crossing the Atlantic instead of 7 days, only in 3.5 days, by taking a very nice design of ship, but putting a huge engine. Typically, if you look at container ship, you have about 60,000 horsepower. They want to take almost 6 times larger engine, okay? And they believed, and when you look at the freight rate, it would be 2.5 times the ongoing freight rate, but they compared themselves to air transportation. Air transportation is 10 times larger. So they thought the sum of the air freight will go to ships because they will provide a better service. Now, what's interesting in the design here, that what you have here, it's not regular cellular vessel, but they put the containers on rail cars, double stack, and they slide in a whole string of cars. We'll see it in a second. The hull is semi-planing, but because we have no naval architect here, let's leave it. Now, this is a terminal. As you see here, there is a special bridge here where you take string of cars, you arrange them here, and you shove it in and out at a rate of 750 TU per hour, which is very nice, except that you need to have specialized ports. A regular container port, what we have here in Minas Ziad or we have in Jebel Ali, cannot handle it. So they wanted to build 2 ports, one of them in Philadelphia, which is not a big port city, and the other one in France, in Cherbourg, which again is not a big port city. So first, there was an issue of everything is specialized and the cost. And second, they wanted to connect ports where there's no traffic. So guess what happened? And then the cost was huge. Everything went down. They wanted the US military to take maybe advantage of the new technologies, but they were not taken. The company is still there, but basically the technology is dead. Speed is out. Not exactly, because there was another design which was a regular container ships with 4 stabilizer pontoons, okay, which had conventional containers, so they could go to a regular port, okay, maybe we can go to it, and it was relatively small, 1,500 TUs, was designed by David Giles, and we in the industry were almost confident that it will be introduced, because you can go to another port, to any port. Let's take, for example, New York or Dubai port. One service can offer this type of ships, express service. They go to the same port. Every Friday you have express, and there was good chances it will catch up, except the speed was a killer. Cost of fuel went up. All quick vessels are down. Now, the only one left, speed-wise, is this combat ship. As you see, it's relatively small. 2 of them are operating in the US. The speed is in the 40s, but they are very small, 700 deadweight. Okay, what's interesting about it, if you look at it, it's aluminum. Because if you look at it, it has 2 pontoons on the side. It's very, very stable, allowing helicopters to land here. But the purpose is combat. We believe that this type of vessel will operate coastal services in the US and perhaps here. Because if you compete against trucking, this type of vessel, big, shallow, 4.2 meters, and going at the same speed almost of a truck, 40 knots, which is about 70 kilometers per hour, maybe can beat trucks. Now, another trend. As you know, Panama Canal is going to expand. Until now, only vessels of about 4,000 or 5,000 TEU, as you see, 48, can cross the Panama Canal. Probably somewhere towards the end of 2014, a new lock system is going to be introduced in Panama Canal, allowing vessels which are 3 times larger, new Panamax, I call it NPX, which are 12,600, okay, 2.6 times. And probably in the future, there will be further deepening going to 55 feet. So you might argue that the new Panamax will be maybe the dominant ships of the future. So if you look in 5 or 10 years, this type of vessel may be, you know, the most popular on the major shipping route. Here is a list of ships, maybe one item to look at it. If you look at the dead weight, you can see this is existing Panamax, 67, post-Panamax, which are wider than the canal, going to 74. This is arrangement. If you're not in the port business, not technical, it will not help you much. This is the NPX, which I expect to be dominant. And here is a Emma Maersk, as you see it here. This is MSC Daniela, which is almost the same size as you see here. And this is a Malacca Max. So here you have some kind of a comparative. We should note maybe the most important issue is the depth. As you see, the Panama Canal today is about 12.5 meters. Some of the vessels are deeper. The future Panamax will be 15.2, which means that if you are in the port and if you have a shallow channel, your chances of accommodating these vessels are nil. Now, as you see, there is some kind of exchange between the ships and the port. We have 2 components, the port and the ship. And the 2 of them, I call it dancing tango together, because it takes 2 to tango. Now, the ships are coming with larger ships, and the ports have to provide larger ports. The only problem here that who pays? And the people who pay are usually, at least in the US, also here, is the public, which means we have to come with bigger ports, bigger infrastructure, and then the issue, is it worthwhile? Okay? The question here is who leads and who is led? Okay, some people say that the ship is leading because ships are flexible. They can go they come to the port and say, hey, if you don't provide good facilities, we go to the other one. So the community is getting together, we lose the shipping and so on. So the port are led, and the public is usually paying. This is it, you see who is paying. Okay, now the question is it good or bad big ships? From the point of view of the ports, obviously it's not good. We need deeper and longer channels. We have to maintain the channels. We need larger terminals. We don't have enough waterfront land. We need roads and rail access because of congestion. Also, from the point of view of the line, big ships are not so good. Why? Because they have limited number of ports that they can call. There are limited numbers of routes that they can fill these ships. And there is institutional risk, which you are not familiar here, but if in the US and in Europe, because of the big ships, you have to do consolidation of several lines, then you'll have some kind of a problem with the government. They will say you're a monopolistic setting and so on. If we look at it in terms of system cost, we have the ship cost. As you see, as the size go up, the ship cost is going down. We have the port cost. As the size goes up, the cost is going accelerated, almost exponentially. You know, to go from a port which can accommodate 15 meters to 16 meters could be maybe 50% more cost. Now, if you look at the combination of them, then you will find out that somewhere in the range of 10 or 15,000 TEUs is optimal. This is where the system cost reaches minimum. So you might argue that eventually there will be stabilization around maybe 15,000, but no more. Which means if we come back to this 18,000, and people are talking about 22,000 I've seen in design, it's probably out of range. It will cost us as society more. Now, recent trends. We are in recession, all of you know. You know, I was interviewed by your business newspaper a minute ago before I started, and he asked me, what are the prospects of shipping line, world shipping line? So it's bad. If you look at it, 11.6 of the world fleet now is idle. First, there was a decline in traffic between 20 and 25%. Most ports, if you look at statistics, here less, but most big ports in the world lost in 2 years about 20 to 25%. Now, what is the effect on shipping line? 11.6% of the world fleet is idle. Never before, okay? Now, it's interesting that most of the idle ships are smaller. Only 2 ships larger than 7,500 TEUs are idle. Now, all shipping lines together lost $20 billion. There was no one shipping line that was profitable. It's a bloodbath. Everybody is killing each other, okay? Now, as I told you, there are 770 ships, 4.7 million TEUs on order. So the troubles did not end, they just start. Not only that 11% of the fleet is idle, 36% is just coming out of shipyards. So what are they doing? They're going super slow. It's, again, unprecedented. Vessels that were designed to go 26 are going 14 knots. They're increasing the strings. In your case, Asia, Europe, instead of operating with 8 to 9 ships, they want to deploy more ships, 12. And they are going around. Instead of going through the Suez Canal, they go through Africa in order to save money, in order to employ more ships. Now, the question that we in the industry ask ourselves, what we see here, is it a temporary, or we are going to face some kind of a permanent change in what we call time valuation? If you can go 14 knots and save a lot of money, and we as shippers are fully satisfied with it, maybe for the future, shipping lines do not need to offer services at 26 knots. Which means perhaps that there will be a permanent change also in the design of ships. Why do we have to put so much horsepower? Let's look at it in terms of autos. If the city here says nobody can go more than 40 miles or 50 kilometers per hour, okay, why do we need cars with big engines? So there is some sense that maybe the time valuation that we had, you know, the economy was rushing, and now maybe we are reaching some kind of a slowdown for the future. Okay, we finished with container ships. Let's talk briefly about the container terminal. What is a container terminal? I think that most of you know. We have access channel, we have dock for ships, we have gate. You know what, let's go to the slide directly. Here is a terminal in New York which I use. This is an existing terminal, as you see. Okay, it's a New York terminal. And this is a new one. Let's look at the component. You have berth where the ship is being docked. You simply tie the ship, okay? You have the dock itself where you tie the ship. You have the marshalling yard, which is basically inventory, parking lot for containers. You have an intermodal yard. This is a US creature, which means it's a rail yard. In the US, we cross the entire continents with rail. For example, most of the containers to New York from Asia are not coming by water, but by land. The containers are discharged in Los Angeles, Long Beach, other ports, put on rail, double-stack rail, and goes 5,000 kilometers until they reach New York, instead of going through the Panama Canal. The same thing for New York, for example. They want to serve Chicago. So, important element is to put here intermodal yard, which is a rail yard, and load the container directly from here onto rail yard, and go 1,000 kilometers to Chicago. It's not here, but maybe now with a rail connection that Saudi Arabia is looking between Jeddah and Daman, maybe you will have a land bridge here. Now, what are the dimensions here? So the Port of New York is considering building, since in New York there's a shortage of land, every piece of land is very valuable, they are trying to expand the port by building a modern, unseen in terms of technology, terminal in New York. The terminal will have 350 meters, it is single berth, it will be 15.2 meters, and the cost is $340 million. And why so costly per one berth? We'll see it in a second. Because what we intend to do there is to use, as you see, automated driverless cranes. Okay? And as you see here also, the layout is in perpendicular to the dock, unlike the layout that you see in Jebel Ali or here in Min Zayed. Okay? The key issue, if you go perpendicular, is to eliminate the aisle space. You can put it very, very tight. Because land is in premium, it's worthwhile for you to invest in technology. Okay? And what you see here, the cranes are rail mounted and automated. The perpendicular, we talked about it. Another technology in terms of port, the picture is taken here in Dubai, is instead of lifting a single box, you can lift two, is common now, and maybe 3 boxes, except, as you see, 340, containers are coming in 2 dimensions, 20 and 40. A 40 is equivalent to 220s. This is the term TU, 20 equivalent unit. So, in order to, because the 2 sizes, you have 1 equivalent. 1 box of 40 is equal to 2 TUs. 1 box of 20 is 1 TU. So what we can take here is 6 containers together of 20 feet. Now, the result of what you need is a very huge crane. And like everything now is being manufactured in China, ZMPC became the dominant manufacturer of container cranes, 75% of the market. China made a big stride, starting from some cheap, toys and plastic and so on, to being a leader in technology. Now, another technology, which is of interest to us, it's called ship in the sleep. What you have here is a sleep here, okay? Indented berth. It's working in one place in the world, in Rotterdam, after sitting idle perhaps for 5 or 6 years. As you see here, the gantries are from 2 sides, and the whole idea was to allow them, they work like this, to allow more gantries deployed per vessel in order to get it faster. And they believed in Rotterdam, by the way, it was financed by the city of Rotterdam, a lot of money to the taxpayer, as usual, and they believed that having this technology will allow them to compete with Rotterdam. But guess what happened? The trade wanted to go to Rotterdam. They didn't want to move to Amsterdam, despite the fact that they have a modern facility. Only later on, when the terminal was bought by a shipping line, NYK forced the ships there. So now it's working finally. Again, if the technology will be dominant in ports or not, it's a different consideration. It's obviously different. You have to design it to begin with. We should not dwell on it too much. Okay, the sleep is designed for 22 wide ships, 22 rows of containers. Another trend that I was an advocate of it is pure rail port. Some ports in the US, we talked about the land bridge. Some ports handle almost everything rail. The famous case is Prince Rupert in Canada. I don't know if you heard about it. Prince Rupert in Canada, at the tip of Canada is the closest port to Asia. However, except for some Eskimos, nobody lives there. There's no trade, no cargo. All the cargo goes to the US Midwest, Chicago, and all of it by rail. So what you have there is a pure rail port. So if you have a pure rail port, you can come with a special layout. And what we have here is basically the entire port is a rail yard. So you go directly from ship to rail. Again, this is quite difficult to achieve because what you need here is, you see, you need a facility which is about 1 kilometer deep. Typically, container terminals now are in the 400, 500, and if you look at the existing ports, usually behind them are cities. Where can you get it? So we talk a little bit about the trends. Okay, maybe another trend. If you look at it, let's just go back into it. This is midstream in Hong Kong. Now, the whole idea is that if you go from ship to ship, why do you have to go through the land? So there was idea of floating terminal, which, as a matter of fact, you can find it now in Hong Kong. If I remember well, they handle about 4 million TEUs in this way. What you have here, you have barges, string of barges with cranes. And the barges are attacking, the vessels from two sides. And they move the containers from here to here to here, and then they go to all the Pearl delta, all to the small river ports. So the whole idea that if the end destination of the cargo is somewhere upriver, why go to a terminal and spend time, spend money? Go directly to barges and all the way to your final destination. Now, if you look at it, we in the US also were playing with the idea here of using ship-to-shore and barge. What you see here is a design and a friend of mine, by the way, Mike Jordan. Mike Jordan, now is in mid-70s, was the one who invented the gantry crane. As a matter of fact, his first gantry crane is still working for demonstration in San Francisco. You can see it. Very, very small, by the way. But he came with the idea of the A shape and so on. And he was also involved with here. The whole idea is to take here two pontoons, run gantries on two sides, and barges in between them. Which means if you have containers that are going to the hinterland here, you use them from the ship to shore. If you want to go to another feeder port, you can put them on barges. So you can do some kind of a selection and avoid for these containers the terminal here, go directly, save money, okay, and save time. Now, I also developed some kind of a futuristic scheme. The idea of floating port, especially we'll talk about transshipment, was always, bugging us in the industry. How can we do it better? So here is another idea. Instead of lifting one container, you can lift a group of containers, as you see, 32 TEUs, which is 320 tons, and we have done it before in barge system. And you can use barges, okay, which can be used for both storage and transport. And if you use gantry cranes that run, okay, these are vessels. Supposedly, the big vessels come to a harbor. Two crane vessels like this are coming on two sides with gantry cranes and barges in between them. You can take a group of containers, all of them, supposedly you come to Dubai or Abu Dhabi, and you have 1,000 boxes that are destined to Iraq. Instead of going through the terminal and handling each one of them, you can use a group of them, put them on barges, special barges, and go directly. Crane carrying and so on. So it's very, very futuristic. This was a terminal, and now let's go to our main issue, which are the services. Again, we start with a little bit of history, containerization, went to the components, the container ship, the ship itself. Everything is very brief. I know if you are not exposed to the industry, you're probably at loss now. And then we talk about the container terminal. And now let's talk about the service, okay, that combines everything. What is a container service? You know, when I have to give a simple example, I say it's like a bus. Okay, instead of a passenger, you have containers. Instead of the bus, you have a container ship. So you have a trade lane. You have two regions in the world, okay? Each one of them has several ports. For example, if you look at the Gulf and you look at Asia, in Asia you have ports ranging from Singapore all the way to northeast China, Tianjin or who knows. And here you have all the ports here in Abu Dhabi, Dubai, you have Daman, you have Bahrain, you have Bandar Abbas, you have many ports. So you have service between group and group. You have a rotation, how you go through them, and you have a frequency. Almost all services now are weekly, but 10 or so years ago, many services were monthly, every 10 days, 12 days. Nowadays, it's the same day of the week. Now, you need several ships to provide the service. We call it string. For example, if you want to go from Asia to Europe, it's 8 ships. If you want to go from Asia to the US West Coast, it's 5 or 6 ships, and so on, in order to provide the weekly services, okay? Now, you have the service pattern. How do you do it? How do you go? How many ships to deploy? What ports to call? And eventually, you have a service network. Shipping lines do not provide a single service. It's like a bus company. They don't have only one bus line. They have several of them, and they try to tie them together to provide a network. And this is what probably is typically, as I see it, the most critical, okay? And this is how you get into this issue of transshipment, which is so critical to this region. If you have services which are tied to each other, you have to move containers from ship to ship. We call this transfer transshipment. Now, why transship? Why do all this transshipment? First, it lowers the lower ship cost. Instead of taking the big vessel and going to all the small ports, you can go with the big vessel only to the main port, and then take small vessel and do what we call a feeder service and go to the small ports, and you lower the cost. The second, you can expand. If you have big and small, you can call more ports, and we'll see it in a second. The third is perhaps even more important for this region. Many ports cannot handle big ships. Simply, they don't have the depth, they don't have the equipment. So in order for you to call them, you cannot come with the big ships. You have to do transfer from big to small. So, and if you look at worldwide port, most of the transshipment started because of limitation, by default, by constraint. They couldn't come. If you look at Mina Zaid, I don't know, a couple of years back, the facility physically could not handle big ships. So the big ship came to Abu Dhabi, and from Abu Dhabi, you had a feeder, a barge, okay? So physically you couldn't handle the big ships. You created the need for small ships and to move from big to small transshipment. Now, there is always inherent trade-off between transshipment. Obviously, if you do transshipment, you have another move. You move from ship to ship, costs you more money. On the other hand, you save on the vessel cost. So there is trade-off. And the last issue is what we call level of service. Is it faster or not when you go through transshipment? And the argument for and against, should not get into it now. Type of transshipment. Let's go through it quickly so you will see it. The first transshipment, which is the most basic, is what I call end-to-end relay. So what do we have? We have here one service between A and B, the other between B and C. Now, we decided in B to do transshipment. So, which means to move the containers from ship to ship. What is the result? That we have a new service, A, B, C. Before we have two separate services, A and B, B and C. And somebody said, hey, there's a lot of containers going from A and C. How can we serve them? Let's do transshipment in B. Let's see what is the result of it. Before that, port B handled only B. Now the port handles B plus twice the cargo that is flowing from A to C. The port B became a hub. Supposedly, port B, A and B and C, each one of them is 1,000. And now there's another 1,000 that move from A and C. First, you have to discharge it and then to load it. So you add transshipment, you basically has a multiplier of 2. Suddenly, port B can grow 2 times or 3 times. This is the most primitive transshipment. Another transshipment, okay, we have 2 services. One of them, A to B to C, and the other one is DBC. Now, you see that there is some kind of a parallel here. Why for the 2 vessels to go in parallel? Hey, what can we do? We can do transshipment in B and eliminate this, the D to C. And what is the result? Suddenly B, instead of just handling its own cargo, adds twice what's flowing from D to C. This is middle to end transshipment. Let's continue. This is very common in airline intersection. You had 2 services which were unrelated, as you see. One A and B, the other B to D, and the route were very close. Somebody said, hey, why don't we put a hub? They will stop in the middle. And look what happened. The hub suddenly handles all the flows, twice AD and so on. And the intersection ports are basically the ports of the future. Singapore is a typical intersection. Singapore has north to south, between Malaysia and Indonesia and whatever, and then they have east to west, from Asia to Europe. And they meet in Singapore, which created the largest port in the world, Singapore, about 30 million TEUs. Now, just bear in mind that what we are talking here is only mainline, no feeder. Just by putting mainline together, we allow now much wider coverage, but the result of it is suddenly we have here a giant port, which has no cargo of its own, but it's much larger than the other ports. Okay, in Singapore, 80% or so of the traffic is transshipment. Singapore is a small island. They don't do much there. They just match. And you have the giant port. Now, let's talk about transshipment involving feeder services. We had a service like this, it's bypassing. We have A, B, and then the small ports, B in the middle. What can we do about it? Big ships should not perhaps call in B. So we have a service. Now they decided to eliminate B. Why eliminate? Because it takes time. Many times there's deviation, you have to go, and there's not much cargo. And instead, offering a small feeder service. So now we introduced a new service, a feeder service. What is the impact of it? Suddenly A handles itself plus twice what goes to B. So Port A didn't do anything, you know. There's no more hinterland, no more cargo or trade. Simply a line decided to change the rotation, and bonanza, the port is becoming hub, maybe increasing the traffic twice or so. Very similar, it's tail cutting. What is tail cutting? You see the small port here, it's the end. What we can do, we had a service ABC. Okay, the main line decided to eliminate the long route to B. to introduce a small feeder. Suddenly C becomes a hub and handles twice B. This is common in very, very long route. I know I'm coming now from South America. I was involved in ports in Brazil, Argentina, and if you know, Argentina is a very shallow port. And bigger ships are being introduced into South America. So the shipping line, I was in contacts with Maersk and Hamburg Süd are starting to toy with the ideas that instead of taking the big ships and going down to Argentina, maybe they should cut the service somewhere in Brazil, say in Santos or in Rio Grande, and from there take a feeder. The same thing on the other side, if you look at South America. South America is very, very, very long. Chile is on the tip. Peru didn't have a modern port. Now DPW is introducing a new port. I was involved in it a little bit. And Peru might become a seaport like this. Instead of taking the big ships and going all the way to Chile, maybe they can stop in Peru, introduce feeder, and what will happen to Peru? Double. For example, Peru now handles about 1 million TEUs. Chile is also 1 million TEUs. If they eliminate Chile, theoretically, let's see if people catch it. If Chile is 1 million TEUs, Peru is 1 million TEUs. If we eliminate Chile, how much traffic we can generate in Peru? I'm sorry? Yeah, exactly, 3 millions. Twice Chile. So suddenly, the guys in Peru are very nice, obviously. They didn't do much. But somebody maybe in Copenhagen or in Hamburg is Hamburg Süd, the Copenhagen is Maersk. I don't know what, maybe in Shanghai, CSCL or whatever, said, hey, why should we go with big vessel all the way to Chile? Why don't we stop in Peru? The Peruvians didn't do much. They have a nice facility, but they didn't do much. Suddenly, from 1 million, they go to 3 millions. Because of all this system, all ports are related now. Let's go to another model of transshipment. We have, again, a service going ABC, as usual, by now, yeah? Okay, and the main line decided maybe they should not call directly at any one of these ports. Why do the milk run? Why call every port there? What we can do is eliminate the direct call, take a hub somewhere in between them, do a feeder services, or one service, a loop between them. Okay? Now, call with the main line, only the hub, eliminate all the free port calls and the time of the big ships and so on. And look what happened to the hub. The new port doesn't have any port of its own. It is what we call pure transshipment port. That's only transshipment. Okay? And it can be done only for one service, could be done for several services. But even with one service, the new port, the port of nowhere, became twice the size, okay, of all these ports together. Okay, if each one of them was handling 1 million TEU, this guy will handle 6 million. Suddenly, we created port from nowhere. Okay, if you look at Malta, for example, in the middle of the Mediterranean. Look at Freeport. Freeport is Bahamas. It's an island. I think that in Freeport, Bahamas, there may be maybe 50,000 people also living. The terminal there is a pure transshipment port. There is no gate there. Have you seen a container terminal without gate? Nobody goes through the gate. Everything is ship to ship. I went to Giatao. Giatao is in Italy, middle of Italy, in the mafia area. And again, there was no gate. I asked them why there's no gate. They say 2 reasons. First, it's very dangerous. Okay. But second, there's no need. Everything is ship to ship. So we have some kind of a new term. New ports are emerging, which are pure transshipment ports, which supposedly will be the largest on Earth. Okay, land substitution is very common. You had a service, okay, which, okay, went. Let's run it again. We had A, B, and A, C, and B. And B was contracted or served by land. Land is supposedly more expensive, so they introduced a small feeder to B. It's somewhat common here, and we talked about coastal shipping. For example, in the US, there's no coastal shipping. You cannot go by ship, say, from New York to Miami or from New York to Boston. Everything is by truck or a little bit by rail, mostly by truck. And trucking is very, very expensive in the US. You're talking about $1.50 or up to $2 a kilometer. Theoretically, there is a possibility that we will replace land transportation by water. As a matter of fact, the US, the Department of Transportation, the Ministry of Transportation in the US has been trying to promote coastal shipping for many, many years. I myself did 3 or 4 studies, and one of the issues against was port cost. To go to water and from water was too expensive. But maybe with some kind of a better technology we can do it. What is the long term? Maybe we should not go through all of it. People all the time ask me, so what is the future? Transshipment will grow, not grow. Let's look quickly into the argument. What is for and what is against? If the trade grows, there is a tendency for shipping line to offer more direct services. And we will talk about in a minute about the Gulf. For example, if the trade of Iraq will reach several million TEUs, I assume that clients will tend to provide direct connection to Iraq, or to Daman, or to Bandar Abbas. So once the trade grows, it goes everywhere. Shipping lines tend to offer direct services against transshipment because the ports justify direct call. And there is one thing that people are talking about, it is a shuttle, even a shuttle. We were looking in the US for a shuttle between 2 ports, Shanghai and Long Beach, just going back and forth, because there's so much cargo, which can maybe fill a whole vessel, a post-Panamax vessel, and can justify, and in terms of cost of production, the shuttle is the best one. Vessel is losing money when it sits idle in the port. So if you call only 2 ports, if you can fill the vessel, then nobody can beat you, first. Second, you have the best service. It's a shuttle. So one argument is that as a trade grows, you may have more direct services. On the other hand, the vessels are growing. Larger vessel will be introduced, so maybe there will be more transshipment. Let's go all the way down to my expectation. Generally, I would say that maybe the common belief in the industry that eventually transshipment share will rise from probably now at around 27%, maybe all the way up to 50 years. It may take time. And the main argument is basically the cost of transshipment. What we expect that through better technology, and you saw it, the cost of transshipment will be much lower and it will be done in a more efficient fashion. Once you beat the cost of transshipment to say, numbers that I used to throw is about $40 per move or something like this, if it's possible, and it probably will be, then transshipment will take over. Now, there is something maybe futuristic that we were talking about. In the year 2000, we were sitting all together and we were asking ourselves, what is the long-term future? What is the best system that can evolve if you can do transshipment, if you can do multiple transshipment even, okay, not one and several times. If you have all the freedom to play, if you are playing God, okay, and you can play with everything, what is the best system that can emerge? And the best system is to go around the world through Panama Canal, Suez, Sumatra Straits, okay? At the narrowest, I would say, waistline of the world, with big ships. The idea is that if you can go in two circular services, in two directions, you can perhaps handle maybe 50% of the trade of the world, okay? And as a result of it, you have 6 or 7 hubs on this around the world, and you will have feeding by mainline only that go north and south. So it's some kind of a global grid. As I said, I'm going to go back. I have a small website, and you can read it. It was called the Fourth Revolution. There is a whole discussion of the emergence of trends in the industry, but we wanted what we call to push the system into its logical end. If you have all the tools, if you can play with it, what kind of system? If you will find out the circular system is the best one in terms of operation. Let's take an example of bus. If you have a bus going from station to station, if you are at the station before the end, the only one left on the bus are the passenger for the last station. The bus is almost empty. Every time you go back and forth, at the end, your vessel or your bus is not fully utilized. So in order to overcome the idea of ends, you have to go circular. The circular pattern is the most efficient. So around this circular, if you build north and south, you can probably serve the entire world. Maybe one small story here. Supposedly, if you do this type of service, then if you want to serve Asia to Rotterdam, by the way, it was introduced in a conference in Rotterdam, and I probably took it by purpose, then you will go to somewhere in the Gibraltar, and the same service that serves West Africa will take the boxes here and go to Rotterdam, which means that Rotterdam will become basically a feeder port to some extent. They will not see the biggest ship on earth. And of course, the guys from Port of Rotterdam were a little bit irritated because they went to the government and said, we need to go to Maslavka, 18 meters of water, and every taxpayer should put, and so on. So nobody knows what will happen. We are talking about very long future, but there is possibility. Some elements already happened. Now, the key issue is that because of all this transshipment, hubbing, and so on, we suddenly have some kind of hierarchy. Some ports, as you see here, okay, are global hub. They have all the direct services calling there and so on. And one example is Dubai, Rotterdam, okay, Singapore, and so on, become a hub. Other ports are becoming just gateway port. They have no transshipment, it's only direct ports. Okay, and there is in between, and there are ports which are feeder ports, the smaller one, and there are some mixture of ports, and in the future we'll have pure transshipment port and all rail ports, which means instead of having just a plain vanilla, as we say, just a port, suddenly you have big ports, global hubs, and there are feeder port, in between gate port, and all ports compete. All ports compete against each other because it's not a single port. Some transshipment can come and suddenly eliminate you. You don't have direct because they go to another port. So there's all these system peculiarities. Which port is going to be the hub? Every port authority in the world is sitting on the issue, believe me. I was a port planner with the Port of Seattle in the 80s, and we wanted to be the hub. Okay, everybody. So who is going to be the hub? One argument is the largest port, okay? Because it will save handling cost. Another one is the closest port. If you have a service, for example, going from Asia to the east coast of the US, the first port of call is Miami, perhaps. Why continue all the way to New York and Halifax? Maybe stop there. So it makes sense there. Another one is centrally located, because if you have hub and spoke, if you are in the center, you have the advantage. And the third one, which is usually the dominant, the best, the one that offers the best deal. Okay, I did a whole study in the Caribbean for a new port, by the way, in Haiti. Just Haiti. And people ask me, why have a major feeder or transshipment hub in Haiti? Well, the argument was very simple. Cheapest. When you do massive transportation transfer, even $10 is very important. Another argument here is highest productivity, of course, less congested, and here's line-owned terminal. If you look at modern shipping, many shipping lines would like to control their terminals. So if you have your own terminal, obviously you do your transshipment in your own port. Some people, we have a APM terminal, which is considered supposedly a separate entity for Maersk, but if you'll find out, you see that Maersk usually calls there. So there is another argument. Okay, we went through another issue, and let's look a little bit about strategic issue. Now that we supposedly are expert in ports and shipping, let's look at the setting of two ports, New York and Abu Dhabi, Dubai, and let's look at similarity, maybe a little bit of difference. New York. Okay, let's apply whatever we learned by now to the case of New York. We have a service, typical service, which we call all-water service. Why all-water? Because it's called only by, if you look at the setting here, you go through the Panama Canal, back and forth. It's an actual case, as you see, it's COSCO. Okay, COSCO is the largest shipping line of China, mainland China, very large line, and the one which has the most services between Asia and the US, and this is one of their services. Calling 2 ports here, 3 ports here. Let's look at the ports here, the trio. New York is by far largest port on the US East Coast. 5.3 million TEUs. TEUs, containers, 20-foot equivalent. We have another port, Norfolk, 2.1 million. And we have a smaller one in Halifax, 0.4 million. Now, what could happen, for example, if we go through the theory that we were discussing before? Supposedly, Halifax being first all the way up, and the smallest, if I'm COSCO, and I would like maybe to call another port, and maybe I'm sitting and say, hey, why should we go to Halifax only for 400,000 TEUs? Why don't we do what I said before, tail cutting? And maybe we'll hub Halifax through New York. New York obviously will earn immediately 0.4 times 2, 800,000 TEUs, will reach from 5.3 to 6.1. The New Yorker didn't do anything. But somebody in Shanghai, I visited COSCO, and they were toying with all this service pattern. That's what they do there in the planning department of shipping line. And it's very common. Well, bad for the Halifax guys, because probably what they will have, in this case, a small feeder from New York, a barge maybe. So probably the taxpayer there in Halifax, if something like this happened, will come and say, why we invested so much money in cranes for a barge? So it could be a disaster, okay? Another possibility is that they will say, why should we call it Freeport? Maybe we can call only it New York. So if they eliminate Norfolk, suddenly New York will get another 4.2, almost doubling their size. Sorry. Another possibility is that maybe one of the arguments is New York is so expensive and there's shortage of terminals. Maybe instead of going to New York, we will hub at the first port of call, Norfolk. Norfolk is a relatively a new terminal, has now automated terminal, has plenty of land. What will happen in this case? New York will have smaller ships, maybe a barge, It's obviously unbelievable to happen. And what happened to Norfolk? Norfolk will get 5.3 plus 0.4, it's 5.7 times 2, 11.4 million TEUs, from 2 to 11. This is obviously theoretical, but for a single service, it may happen. And nothing happens. The ports are the same, the trade is the same, just because of lines playing games, because everything is related now, everything is network. It's what I say, that this idea of network is playing havoc in our industry. Now, there is another, perhaps, possibility here. We were toying again with the idea of what will happen when Panama Canal expands, especially for the US East Coast port, against the service pattern. So one possibility is that nothing will happen. The same, the services are going now like this through the Panama Canal, as you saw. So maybe all that will happen is having the same services simply by bigger ships. Another possibility that they will divide. Remember, we say more traffic, more direct calls. Today, they do not call it the Gulf. So they will take this conventional service and split it into three. They will go to the North Atlantic, Central Atlantic, and Gulf. Each one of them will have direct call. Why? Because traffic is larger and it justifies. And finally, it could be that maybe some kind of a round-the-world service will go here and will maybe stop in one port, okay? And the port could be perhaps Guantanamo Bay. I don't know if we'll give it back to the Cuban. Okay, it will be a nice jest. In this case, there will be a feeder services from here, and the feeder service will take Asian cargo, European cargo, and South American cargo, which means all the services from Asia, from Europe, from South America will go to one hub, maybe in Guantanamo Bay or somewhere else, which will be much larger than any port. Okay, if you look at the port here, if this scheme is going to happen, okay, this port might handle maybe 25 million TEUs. In Guantanamo Bay, there's no container now, okay, or in Cuba or somewhere else in Caribbean. Suddenly, because of the change, there will be a giant port. What will happen to our friends in New York? They will be fed. It will be a feeder port in this case. So what are the strategic issues of New York? Let's finish with one port and go to the Dubai, Abu Dhabi. Okay, what is for New York? Okay, New York is the largest port by far. 5.3 million TEUs. The second port, Norfolk, is only 2 million. So it's by far more than that. The cargo to New York is captive cargo. 80% of the cargo in New York is within 300 kilometers. You cannot call a Norfolk and truck to New York. It's too expensive. Might cost you more than the freight from Asia. Trucking for Norfolk could be maybe $1,200, $1,500, which is exactly what is a freight from Asia to New York. So basically, New York has captive cargo. It's a big advantage. Second, New York is a dominant. They have all the terminals, all the technology, everything is there. They have rail yard and so on. And third, when Panama Canal expands, bigger vessels will tend supposedly to go to bigger ports. So New York may enjoy more than the rest. So these are the pluses. What are the threats? In New York, there is a shortage of facilities. Okay? There's no more new large terminal. All the waterfront practically is taken. We cannot establish a new big terminal like Mina Khalifa here. No way. You cannot find even 100 hectares somewhere. No way. Second, channel. A channel in New York is going to be 15 meters in a year. To go from, in order to get big ships, you need 16 and 17 meters. The cost is tremendous, we'll see. To deepen the channel in New York might be $2 or $3 billion. And there is also a beyond bridge, there is a bridge, I don't know if you heard about it, that big vessels cannot go through it. So they have physical limitation. Now, there are non-US transshipment hubs that can do tail cutting in New York. There is a Halifax, Melford. If you look at geography, if you come through the Suez, Canada is first to US. And in Canada, you have plenty of land, deep water, natural. So there might be a situation where the ships will stop at Panama, outside of the US hub, and go with small ships to New York. Could be the same thing on the south end. You saw Cuba, you saw the Bahamas. So New York faces also competition from outside the US. You might ask yourself, what is the connection between New York and Cuba? Why they are competing? It's different cargo. No, it's not different cargo. Because the big ships can stop at Cuba and send smaller ships to New York. Okay? And the third issue, we talked about it a little bit, the intermodal competition. As I said before, most of the cargo is still coming from the US West Coast by rail. And there is a big competition between the East and the West. Why the Port of New York is competing against Los Angeles? It's a 5,000 kilometers difference. There are two different shores. But if you go to Los Angeles and Long Beach and look at the cargo composition, 40% of the cargo in Los Angeles and Long Beach is 15 million TEU. 6 to 7 million TEUs do not go to California. They cross California all the way to New York. Double-stack trains you don't have here. We have trains in the US which are 2 kilometers in length, can take up to 550 TEUs, one train. It's like small ships. So suddenly you have weird competition, and they might improve the land bridge services, which they are trying to do. So the competition also from the West Coast. So you have some advantages, some disadvantages. There is a dynamic here. We talked about it. Let's go to our place, Dubai and Abu Dhabi. As I said before, the two ports are basically the same. It's, I believe, between Jebel Ali and Mina Khalifa is what, 20 kilometers? About. So if you look at thousands of kilometers of deep sea services, the two of them basically are part of one complex, which is here in the entrance to the Gulf. Here are the ports, as you see it here. You see, the two ports are basically combined together. There is regional competition here, and also outside competition from port outside the Gulf. Okay, you have for Fakan, and you have other, and so on. Sohar especially, we heard about them recently. Now, I don't think that we should go over it because you know it better than I. This is a nicety. The New Yorker were open eyes. You look at all this. Where is it? Of course, you have very nice all this. Okay, Port Rashid, the historical port. Okay, and then Jebel Ali. Maybe continue. This is a master plan of Jebel Ali, as you know better than I, perhaps. Huge master plan. So what you have here, you have cargo generation here. Okay, about 50% of the cargo flowing to the free trade zone, a little bit to Abu Dhabi and so on. But you have local generation of cargo. And I looked at the feeder services of one carrier, Maersk Line. And what you find out, there's many, many feeder services. Most of them are based in Jebel Ali in Dubai. For example, there is a service to Bahrain and Abu Dhabi, was probably now will not be, to Doha. There's another service here to Bandar Khomeini and so on. Another service to Shuwaikha, Kuwait. Another service to Qasr, Iraq. Another service to Kuwait. Another service to Out, Muscat. Another service here. Okay? There is a network of feeder services now that basically made Dubai into a hub. The question, and I was asked by the journalist, is it a stable situation? Are there threats? Are there opportunities? So the model that we have now is that most big vessels do not go to the upper Gulf or to the inner Gulf, come here, stay in Dubai, discharge or load the cargo for the entire region, and go back. Which means you have a vessel coming from Asia, coming in, going out, or going to Asia. Or a vessel going from Asia to Europe, coming in and out, which creates a huge hub here. However, as we said before, most of the transshipment was created by constraints in the secondary ports. However, as you know, in Daman and Bahrain and other places, people are introducing new container terminals and they generate more and more cargo. A shipping line, transshipment costs money, and also the service supposedly is not good. They may have the tendency to stop maybe in Dubai and go maybe to Bandar Abbas, maybe a little bit here, but they may continue with a big vessel, main line, and call, for example, at Daman. So if Daman has 1 million and something TEUs, and the service is not feedered through Dubai, Dubai obviously will lose twice, okay, the traffic in Daman. So there is a threat that shipping line, now that there are modern container terminals available in other Gulf ports, and there is a lot of traffic because they developed, will say, hey, competition, let's go to Daman directly and offer them a best deal in the world and so on, which will be at the expense of transshipment in Dubai. Okay, 50% today is transshipment. Here we have 1.25 million that theoretically 2.5 million could be lost in Dubai. Another possibility, you know, the Strait of Hormuz is somewhat problematic, and there's a deviation. So maybe if the ship size is growing, they might decide not to enter the Gulf at all, and maybe do some kind of a hubbing at one of the ports here. For example, Hofakan, already 3.1 million TEUs doing. Instead of taking the big ships and waste maybe 2 days going in and out, maybe it could be better to stop outside the Gulf, not to fool around with the Hormuz, you know, there's navigation and storage, political risk, who knows. Now, as a reality, before I left, 2 lines, one of them is China Shipping and the other one CMA CGM, announced a modification of the Cymex services name, which they call new. They take now 6 modern, very large, 8,500 TEUs vessel, okay? And they added a call in Daman, which before that was transship, okay? And also they added ports here in this area. Since they have so many idle ships, they decided to put more ships into the service and call directly at more ports to avoid transshipment and provide better service. So it's not just a theoretical threat. Some lines are already doing it. Another threat, which has some similarity to New York, is a land bridge. Okay? You can call it Hofakan, and instead of going by water, you can go by land. It's not far away. Same thing with New York. Instead of calling New York, you call Los Angeles and go by land. And there is another possibility that some feedering can be done totally outside the Gulf region. For example, Jeddah. You know, Jeddah, RSGT and so on is building a huge terminal. So if you want to go to Africa or somewhere else, East Africa, maybe you can do it from Jeddah. So let's do the same dynamics here, the plus and the minus. We are still on time. So what is the plus first? The plus is that we have our own cargo in Dubai, Abu Dhabi. There is a FTZ, there's a lot of production here. And lines have to call here. there is local cargo, exactly like in New York. Local cargo, huge local cargo, the largest in the Gulf. Nobody generates so much cargo as Dubai, Abu Dhabi. The second, that until now at least, there's superior facilities. The facilities in Dubai, the operation, DPW, is first class. Nobody is getting close to them yet. So they have technological superiority, and they have the biggest cargo, which more or less assure to them, at least for the time being, that they will remain the hub. What are the threats? We have in-Gulf regional ports, which are induced by direct services, which can cut into their transshipment, and we have out-of-Gulf hubs, okay, especially the Asia-Europe services that go from Asia to Europe. Instead of getting, the bypass, instead of getting into the Gulf, they will bypass the Gulf, go directly, and perhaps call in some out, maybe in Aden, in Salalah, some ports that do not require big deviation. So if you look at it, there is very similarity. The two ports, New York and Dubai, Abu Dhabi, now enjoy superiority. They have the cargo, they have superior facilities, but the two of them are facing competition, from neighboring ports and from out of the neighborhood ports as well. And this is it. Now, again, as I said before, I have a nice website, I hope, and there's much more on these issues. You're welcome to look at it, and of course, welcome to ask questions. Thank you.
Hi, I'm John Burt. I work here at NYU Abu Dhabi, and I'm also interested in ports, but from an ecological perspective.
Okay.
But I'm not going to talk about that now. What I'm interested in is it seems that a lot of the issues with transshipment rely on the fact that, or are based on the fact that land is expensive, and that you get an aggregation of ships at one place and they can't all offload at once without logistic problems. Here in the Gulf, we have sort of an ideal situation compared to the States in that you can build land in the sea very cheap. The water is very shallow. The sediments are typically sand unless you build it over a coral reef. And this might be one advantage that Abu Dhabi and Dubai have over New York. And I just wanted to get your thoughts on that. You can build
It's correct.
offshore islands that, for example, the Palm Island has, in terms of linear shore frontage, it's ideal for a container port.
Let's relate to a couple of issues. First, the cost. Yeah, you have plenty of land if you can reclaim. Reclamation is very expensive here. Maintaining channels, deep channels, is also expensive. So on the cost side, your ports are expensive. You have land, correct. To reclaim costs a lot of money. To maintain a deep channel, you need breakwater here. There are no breakwaters. So it's not cheap, first and foremost. Okay? Now, in New York and also in Los Angeles, in the US, I assume that you are from the US, we have a definitely shortage of waterfront land. There's competition on the waterfront land. It's very difficult, in Los Angeles, Long Beach, if you want to reclaim 1 hectare, you have to provide a substitute hectares of waterfront land somewhere else. One case, which is outrageous, if you go to visit the port of Tacoma, in the middle of the port of Tacoma, there is a fenced area. Inside it, there is a marsh, just marsh, with nothing, just shallow water, mud, and whatever. And when you ask them, why do you need in the middle of the port? Is it ecological? Is it some kind of a zoo for the people to learn about birds? Say, no. We built a new terminal, and we had to give back tidal land, okay, to the environmental authorities. So the US, or if you look at the way we build ports in the US, because of our environmental constraints, first it takes years. And second, the cost is horrendous. But here, it's also costly. So the cost is still an issue here. Now, but if you look again at Abu Dhabi, Dubai, okay, if you look at Abu Dhabi, Dubai, the story is, I'm sorry, if you look at Abu Dhabi, Dubai, the issue is not shortage or availability of land, because in the other Gulf port, you have also plenty of land. If you want to reclaim here, we can reclaim in Doha, we can reclaim in Qatar, or in Qasam, or in Bandar Abbas. So it doesn't give you do not compete yet with the Port of New York. Okay, so you compete maybe with Salalah or maybe with Daman, and they are in the same setting, basically. So relatively, you don't gain. So it's nice to have plenty of land, but it's not really something that which is missing, you know, at your competitors. So it's not an advantage. More questions?
Hi, thanks, Professor.
Sure.
Sid Jofi, Teach for All, an international education nonprofit. A very simple question. What's the legal status of the ports, the PTPs that you were talking about?
The legal is nothing. If you look at a typical PTP, let's look at a couple of them today. In Bahamas is a bunch of islands which are independent, basically, across from the US. And what happens there, probably one of the few ports in the world where there is a private port authority. If you look at the institutional setting of a port, usually you have a port authority which is in charge, the owner of the property because it's a national asset, and also in charge of the water access and the land access, the channel and the land. In the Bahamas, the Hutchison guys got the authority for a private port authority. They have everything, the channel and the land and so on. They got it for 100 years, 99 years, with, if I remember a possible extension for another 100 years. So it's basically ownership. So it's a private port, and it's a regular port. Of course, it's a territory of the Bahamas. So PTP is not different than any other port. It's just a transfer. It transfer port from ship to ship, and they have the potential, you might say, the explosive, because transshipment generates so much traffic. They have the potential to become the largest port. If you are in Panama Canal somewhere on, if you look at port of Balboa, for example, Balboa is on the west side of the canal, on the entrance from the Pacific. Balboa was a breakbulk port until 7 or 8 years. Nothing there. Maybe 20 or 30,000 TEUs at all. Hutchison, in this case, got a contract with the Panamanian government. Later on, they went to court. I was one of the expert witnesses there. And what happened that all the Asian cargo to the west coast of South America, or not all, but large chunk of it, is being transshipped there. And suddenly, within a couple of years, they're starting to handle 2 or 3 million TEUs. Giant port. Where is the cargo? You know, the Panama is a small country. There's nothing there. They don't do anything. They don't grow anything, believe me. A little bit of melons, a little bit of bananas. We try to help them with the melons, with the reefer facility, nothing. And suddenly they handle so much. Look at Malta. Malta, if I remember well, out of 1 million and some TEUs, only 70,000 TEUs went to Malta itself. So PTPs are ports like every port, except that instead of handling from sea to shore, sea to sea. More questions? Go ahead.
I work for Abu Dhabi Ports. My question is how, let's say we want to decide on a system to be applied for containers, manual, semi-automated, or automated. Obviously, there is the cost factor and productivity factor. What is your advice on that. What are the major sort of considerations that the port should take into account for that?
Maybe I can tell you a related story, as usual. About 7 or 8 years ago, the port of Norfolk in Virginia wanted to do an automated system very similar to the systems that they have in Singapore, what we call bridge cranes. Right? The cranes are on columns, and there is a beam which runs above, 10 high, 10 wide. And underneath the big cranes, to put straddle carrier, small cranes that can go back and forth. And it was very nice technology. Now in the US, cost of labor is horrendous. Everything is unionized. The average cost of a stevedore labor is about $75 now. $75 per hour. Crane operator, crane driver, can earn $150,000 a year. And not only, you have a lot of restriction. You cannot work 24 hours. If you want to work Saturday, you want to work Sunday, it's 150, 200%. Okay, very militant. Some problems are slowed down. So for us to go to automation is obviously a big argument. Also, the cost of land. You have three components in a terminal: land, labor, equipment. When land and labor are very expensive, you go to equipment. So we go back to the port of Norfolk, and they ask me, should we go? Because if you go to bridge cranes, you have to build columns. Okay? It's like building a highway. And once you put it in the ground, you lose flexibility except for the high cost. And it's a port which is a public port. Many lines are calling there. And they come and go, and each one of them would like to have their own separate yard or so on. And that was my argument. Yes, economically it made sense. But strategically, don't tie yourself. Because tomorrow you have to serve another line, they have their own peculiarities, they want to do X and Y. So that's the US. Generally, automation related to labor cost. If your labor cost is not high, and if you are flexible with labor, then you should do automation, but to some extent. Shipping lines, despite what they say, do not care much if you automated and not automated. The shipping line do not care if you work 3 or 4 gantries. They care for one thing, moves per hour. If you want to use 5 gantries, you're welcome. Or if you want to use 2 very highly automated, you're also welcome. So despite, it's very nice to have automated and so on, but if you are not talking about a very high throughput terminal, and if you do not have shortage of land, and if you have flexibility on labor, I would look at it very carefully. Okay? In Rotterdam, if the US is bad, Rotterdam is worse. Okay? Union labor in Europe, Europe is still very socialistic. So it's very, very hard to move them. So they went to all this extreme automation. If you look at AGV, in Europe they operate with trucks without driver. Okay? It's automated, it's moving. But the truck without driver costs $300,000. A regular truck is $70,000. Is it worthwhile? Okay, and you have a lot of complication, how to move them around and what to do. In Europe, it makes sense because you don't have to play with labor. You can work around the clock, and you don't need them if somebody is sick or not sick. Here, for example, in South America, we don't see any automation because labor is relatively inexpensive. So you have to put all of them together, and there are many studies. As automation, perhaps, I would look at more into terminal operating systems, a better terminal operating system before I invest in automation. That would be maybe some kind of a rough recommendation.
But are people still using manual if you want to start a new port, manual operation?
Yeah, still, yeah.
I'm watching the clock a little bit, and there will be some time to talk with our speaker after the lecture. And I hope I may take the prerogative of asking a last public question. You have spoken extremely informatively about all sorts of economic risk to ports that they have to assess, and at the same time the shipping lines assess what ports they go with. How do shipping lines factor criminal risk into what ports of call to go to? And I think, of course, of pirate lines, the dangerous pirate territory, as well as terrorist threats and so forth. Do shipping lines spend a lot of time on that kind of risk assessment?
Let's look at two issues. First, issue of the risk of theft, damage, and so on. It was very popular, I would say, risk years ago. You know, I was once an invited guest of the Port of Manila, and we started to talk. It was day, and then it was night, and I look at the container terminals. There's a lot of flights there. I asked, what's that? I said, they are squatters. What do you mean? They were here before the port, and now they are living inside the port. So how do they get in and out? They have some way through the fence. Okay, people are living at the port. Now, it's a no-no. All terminals are secure, more than that. Most of the terminals have a secure fence with cameras. You know, Peru, we talked about Peru. You know, I was a guest there, and we were sitting there in a room with all the cameras. And the guy suddenly pulled me, said, look. And there was a guy going to a container, opening the container, had a pair of shoes. He put his shoes inside, took a new pair of shoes, put it on him, and started walking towards the gate. He said, see what happened now. The guard at the gate asked him, oh, you have very nice shoes. Are they new? And everybody was watching. So every corner is now under surveillance. Now, if you talk about terrorism, in America, there is legislation that 100% of all the containers, 100% has to be scanned, every container, through some kind of an X-ray or a gamma ray. Now we scan very, very limited number. So nobody knows physically how will you do it, the facilities. Working now in Port of Lagos. In Lagos, already, every container is being scanned. So if you look at the terminal, you have the regular marine terminal. Outside the terminal, you have another terminal, a scanning terminal. So every container is being scanned through X-rays. And there, by the way, in Lagos, maybe 20 or 30% of the containers are being opened, because I was there. A guy declared that he's bringing, I don't remember, some yard furnitures. In the middle, there was a dark hole. What is a dark hole? They stop it, some TVs or so on. So it's a real issue. Scanning and ISPS and all this will change the way we do business. Maybe all the layouts that we see here will change. Maybe every container straight out of the vessel will have to be scanned. So yes, you're right. Terrorism is a big deal. It's very hard to detect radioactive materials and so on, and the US is very, very worried about it.
Thank you very much. Please, all join me in thanking Dr. Ashar and meeting him afterwards for some refreshments.
Thank you very much.